Algebraic Patterns Part 4. Example 2. Single matchsticks were used to form a sequence of patterns as shown. So here's our sequence, and we have 4 terms in the sequence. Find an algebraic quadratic expression for the number of matchsticks needed for each pattern. How many matchsticks are needed for the 10th pattern? So I put a little line, a little dash in red to indicate each matchstick because it can be hard to count them because they're on top of each other. So we can clearly see there are 1, 2, 3, 4 matchsticks forming the first pattern. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 matchsticks forming the second term. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 forming the third term. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 forming the fourth term. So we have 4, 10, 18, 20, 8, ... So writing out our sequence, we find the first difference. To get from 4 to 10, we add 6. To get from 10 to 18, we add 8. To get from 18 to 28, we add 10. So the first difference is 6, 8, and 10. Clearly, they are not the same. So therefore, it's not a linear function or a linear sequence. And we know that anyway because they tell us in the question it's quadratic. So the difference between 6 and 8 is 2. The difference between 8 and 10 is 2. So the second difference is the same, which again tells us it's quadratic. So therefore, our sequence or our pattern is quadratic. So f of x is going to be equal to ax squared plus bx plus c. So this is the general equation for a quadratic function. So to work out what the a will be, we take the second difference, which is 2, and we divide it by 2. So we get half of the second difference to give us the coefficient of x squared. So if 2a is equal to 2, then a is equal to 2 divided by 2, which is 1. So we get 1 in front of the x squared. So ax squared becomes 1x squared. We also know what the plus c is at the end because we just basically take the first term, which is 4. So the first term is 4, and that's when x is equal to 0. So the first term, when x is equal to 0, we get ax squared plus bx plus c. Replacing both of those x's with a set of brackets and 0, we get a times 0 squared, which is 0, plus b times 0, which is 0, plus c is equal to 4. So simplifying, we just get c is equal to 4. So we know we finish with plus 4 at the end of our function. To find b, we sub in x is equal to 1. So we know the a is 1, and we know the c is 4. So we're going to replace both of the x values with a set of brackets and put 1 into the brackets. So we get 1 times 1 squared, which is 1. B times 1 is plus b. And then we have plus 4 is equal to 10. Then solving for b, we get b is equal to 10 minus 1 minus 4, which is 5. So we now know that the b value is going to be 5. So the coefficient of x will be 5. So 1x squared just becomes x squared. The b becomes 5. So we have x squared plus 5x plus 4 is our function. So f of x is equal to x squared plus 5x plus 4 when x is greater or equal to 0. To get the 10th pattern, that's what they ask us at the bottom of the question here. So how many matchsticks are needed for the 10th pattern? We let x equal to 9. Now be very careful. You're not looking for T10 like we do when we're using our nth term. Remember, you're after generating the function of the pattern. You're after generating the name of the pattern. You have not generated the nth term. So you do not sub in 10 in place of n. You're subbing in 9 in place of x. Because remember, the pattern starts with x is equal to 0. So for the 10th pattern, we take 1 away from 10 and we're left with 9. So we let x equal 9. So f of 9 is equal to 9 squared plus 5 times 9 plus 4, which gives us 130 matchsticks. So the 10th pattern will contain 130 matchsticks.